Today's lesson is on factoring special cases, and in order to do that, you have to recognize perfect squares. Do you know your perfect squares? I do. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. There's a lot more. Let's go. Before we learn how to factor special cases, let's do a quick review of how to multiply special cases. So the first one, we have the binomial x plus 9 squared, and if you remember, you can either write it out twice, x plus 9, that means times itself, x plus 9, and then from there you can FOIL it, or if you remember the special pattern, when you have a binomial squared, you take the first term and square it, so x squared. Then you have to multiply these two together and double it, so 9 times x is 9x, and then double it is 18x. And then square the second term, 9 squared is 81. The second special case is almost the same, except we have a subtraction sign instead of an addition sign. And once again, when you have a binomial squared, you can write it out twice, 2x minus 11 times itself, 2x minus 11, and then FOIL. Or if you use the special case, once again, square the first term to get 4x squared. And then to get the middle term, multiply 2x times negative 11, which is negative 22, and then double it. So minus 44x. And then square the second term, negative 11 squared is positive 121. And the last special case is when you have two binomials that are almost identical, except one has addition and one has subtraction. If you FOIL this, you definitely will get the right answer first, but our outside and our inside terms will cancel out because they'll end up being opposites. So we really just have to do our first and our last. So first, 3x times 3x is 9x squared, and then 4 times negative 4 is minus 16. So we just reviewed how to multiply special cases. Now we're going to move backwards and we're going to factor special cases. So we're going to start with what's in the blue and we're going to get our answers, which are in the green. So really, now let's flip it and reverse it. Let me show you how we're going to work it. 'Cause I'm Dana, the explainer, and my math is gonna entertain ya. Here we have two examples of perfect square trinomials. And how you recognize perfect square trinomials, you have to look at the first and the third term, and you want to ask yourself, are they perfect squares? Well, in this case, 1x squared is a perfect square, and 16 is a perfect square, so most likely that's a perfect square trinomial. And then if you look here, you should recognize 9 is a perfect square, and 49 is a perfect square. So once again, most likely it's a perfect square trinomial. It's not guaranteed. For it to be guaranteed, the 2ab has to be true, and I'll explain that a little bit more in a second. But the key thing to remember, that middle term does not have to be a perfect square, just the first and the third terms. Now to factor a perfect square trinomial, think about going backwards when we were multiplying binomials squared. We were always squaring numbers, so now we want to go backwards. So instead of squaring numbers, we want to square root them. So our final answer is going to be a binomial squared, and you square root the first term, which is x, square root the last term, which is 4, and then check the sign. If they're all positive, we're going to have x plus 4 squared. Because now think that last lesson, how did we always multiply this one? We would go x squared, and then you multiply them together and double it, 8x, and then square the last one, 16. So we know it's right. So now for the second one, to factor a perfect square trinomial, we know that our answer is going to be a binomial squared. And then to fill in the blanks, you just have to square root the first and last terms. The square root of 9x squared is 3x, and the square root of 49 is 7, and if we have all addition, our final answer will be addition. And then just quickly check it by going by multiplying. We would square the first term, 9x squared, multiply these two together, 21, and then double it, 42, and then square the last term, 49. So it worked, so that's our answer. Here are two more examples of perfect square trinomials that we're going to factor. They're just like the ones we just completed, except we have that subtraction sign in our trinomial. But remember, the first thing you want to look for to detect if you have a perfect square trinomial is look at your first and your third terms and check, are they perfect squares? So here we have 1 and 144, so we have two perfect squares. And here we have 4 and 81, which are both perfect squares. In this case, that middle term is also a perfect square, but that's just a coincidence. In most cases, that middle term is not a perfect square, and it doesn't need to be. So, once you recognize that you have perfect square trinomials, you know that when you factor it, your answer will be a binomial squared, because we're going backwards. And then to fill in your binomials, you square root, and you square root the first and the third term. The square root of x squared is x, and the square root of 144 is 12, but in this case, since we have a subtraction sign in our trinomial, it's going to be x minus 12 squared. And now for the second one, square root first and third terms. Square root of 4x squared is 2x, the square root of 81 is 9, and then because we have subtraction, it's 2x minus 9 squared. And then if you're ever unsure, you can always check your answer and think about the special case when we have a binomial squared. Square the first term, multiply them together and double it, which would be 24, and then square the last one, which is 144. So it works. Same thing here. Square 2x is 4x squared, multiply these together is negative 18, and then double it is negative 36, and then square negative 9 is 81. Good, so they both work. Okay, the last special case is the difference of two squares, which is really just a fancy way of saying the subtraction of two numbers that are perfect squares, so the difference of two squares. So we want to think about, since we're factoring, going backwards, what two binomials, when you multiply them together, gives you the difference of two squares. So usually when we multiply binomials together, we get a trinomial, ax squared plus bx plus c, or minus. But if you notice, these two don't have that middle term. So at what point were we multiplying two binomials together where that middle term canceled out? And if you remember, it was always when we had two binomials that were the exact same, except one was plus and one was minus, because that would always allow us to cancel out two of our terms. So, to fill in the blanks, just like we've been doing, we're going to square root. The square root of x squared is x, and then the square root of 36 is 6. So we have x plus 6 and x minus 6. And then same thing for the second one. What two binomials, when you multiply them together, gives you 9x squared minus 4? Well, it was always two binomials that are the exact same except one addition and one subtraction. And then to fill in the blanks, we're square rooting. The square root of 9x squared is 3x, so they both start with 3x. And then the square root of 4 is 2, so they both end in 2. 3x plus 2 times 3x minus 2. And remember, you can always check your answer by doing a quick FOIL. First, that would be 9x squared. Outside would be minus 6x. Inside would be plus 6x, which would cancel out. And last would be minus 4, leaving us with 9x squared minus 4. So we know we have the right answer. You now know how to factor different polynomials, and they're ones with special cases that have perfect squares, perfect square trinomials, and the difference of two squares. The next lesson, we're going to combine the idea of a greatest common factor with the special case. So get excited for that, and good luck with this lesson.